Okay, let's finish this lecture up. And we saw UDP before we took the break. And let me talk about TCP, and then we'll talk about RMI. And then we'll take a quick break and then get into the last lecture for this particular session. So we were talking about the differences between TCP and UDP. I've covered all that stuff already. And we ended the last video with this particular example of the simple server and the simple client for the UDP example. And the slide set here is going to give you the reference to the code. It is an S code, and I will include the, I already uploaded the video, the last one we just did, and I included the link right underneath the video with the source code. So if you don't get it from the bhacker.com website, you can get it from the YouTube video link. So the UDP example that we looked at, just to refresh your memory, started a server. The server waited on a port. Then we connected with a client, and the client sent it a message, and then the server sent the message back to the client, as we've seen. And we had the UDP simple client just sit there and wait while the server was communicating. And so we can kind of see that that was a connectionless type of protocol where we didn't have a constant state between the server and the clients. Rather, the clients gave the server, through the sending of the packet, the information regarding its port. The server looked at the packet information it received, diagnosed that the port was a particular port, sent a message back to the client. We tested it with two separate clients, so we could kind of see that the server kind of knew automatically the differences between. So it was really ports, and it can also be IP address related in terms of setting that up. But unless the client sends a message, the server has no idea, and then the server also does not know if the client is connected or not. So the problem with that is what happens if you have a transaction that's occurring. Nice when you're just doing text messages or something, or text chatting, but when you want to keep track of the state and you want to make sure that the client doesn't go away, you use TCP. Obviously, you can probably tell that with the UDP client, it's great for instant messaging because you can have millions of people all over the world sending messages to the client, to the server, and it's not very memory intensive. With TCP, now we're talking about adding some memory issues, shouldn't say issues, but some requirements, where the server is keeping a constant state. So the TCP network is similar, but it fixes the flaws inherent in UDP by providing a message delivery guarantee and concurrency. So we have at any one moment of time concurrently connected clients taking up server resources, because each client that actually connects to the server is actually creating a process for which it's running in, which is why it does take up extra resources. TCP goes a step beyond UDP because it creates that stateful and connection-oriented protocol, as we've seen. All right, but I've talked about so far, we haven't seen it yet. The stateful means TCP remembers that it has sent and ensures that it arrives in the same order, versus the UDP where it just tosses it out. So the connection-oriented means that the packet sent is actually part of a larger conversation, or it actually uses a stream abstraction. So before we saw datagram instead of a stream, and we saw bytes that were held in an array, and that was sent back and forth. So now we're looking at streams instead. So we'll use a slightly different object for that, and in the implementation I'm going to show you momentarily. But the TCP-based server differs because it is a single thread, does not perform all of the communications. It's broken out, actually. So it's different than the UDP-based server. And the usual solution is to handle TCP communications is to create a new thread that is dedicated to the incoming requests from the particular client. So going back to the concept of how this differs from UDP, we have two threads, not one thread of execution that's going on simultaneously. We have a sender and we have a receiver, and it's done to two different channels. Actually, UDP is channelless. We don't have to worry about the channel, and so it's done in sort of a throw the ball across the street. So now it requires more overhead. So a server, because we have two threads instead of one now, but before we didn't have any threads at all. We just threw it out there, and the threads are actually connecting the two ports. So it's basically a thread abstraction. The server can distinguish multiple requests from multiple different clients on the same client system, because each client will be forced to use a different ports. If you noticed in that previous UDP example, we used 7.7. Yeah, we set it on one port, and all of the clients connected to that one single port. Now all of these clients are here going to be forced to use different ports. In fact, you can actually send the same client to the same ports multiple. Yeah, you can share the ports on UDP. You can't do it. You have to use separate ports on the TCP. So the program for the TCP client and servers are similar, and we're going to look at that in a few minutes. Although the details they vary a bit. Because TCP is stateful, we actually open up two streams. One is inbound and one is outbound. And these act as like the conveyor belt or the sushi boats. For if you remember that example I gave you earlier, for the data to flow between the client and the server. And from a programming standpoint, we no longer have to use datagrams. So we won't be seeing datagrams in these examples, but we're going to be reading and writing from the stream. This is actually easier, I think, because if you start looking at that datagram, you actually have to convert that to a string. Yeah, byte to, yeah. You can use it as is, no translation. Yes. So you figured that out already. So for the server, the largest change is the addition of the threads in order to maintain each connection as a separate conversation. So we have multiple threads for each one of the clients versus just an open port. And inside the thread, there's a command that simply reads and writes the data. And the example is going to be TCP Server.java, and we have TCP Client.java. The client is simply going to be similar to the UDP server, except it's going to be sending datagrams. We look up the stream-based plumbing. We hook it up, we put it in there. However, the rest of the logic is pretty much the same. So we have the TCP client as well. And this example is going to look like this, where we have the Java TCP server, and it's going to set up and listen to a port. And the server loads quite easily. We're going to give it the port number on the command line this time, which is a lot easier actually, or better than hard coding it. And you start the server first, and then we run the client. The client we're going to run with the same syntax as the simple one. I'm doing this for my benefit so I can remember the syntax. So same way as we invoke the UDP, we'll be sending it. This will be localhost along with the address. Let's take a look at the source code in a few minutes here to see how it differs. We can see that live actually, and then I'll return to RMI in a few minutes. But let's go out and take a look at that source code. So here's my TCP server, and I bring this up here, make this a little bit bigger, and zoom in a few minutes here. Oops, let's go back up this way. Alright, so it's the same two libraries that are, packages that are being imported. And so we're going to kind of just take a look at the differences between what we just looked at earlier. So here we're going to have a number here for the connection counter. We're going to keep track of all these simultaneous connections. And the main stream is going to take in the port number actually when we start the server. And it's going to start the TCP at this particular port. And so it's looking for one argument, which is going to be the port number. We get the port number to listen to, and we set the server port. So we have an integer, parse integer, which is basically going to take the command line argument, which comes in the form of a data stream actually, and we're going to parse it, the argument number 0, which is actually the first argument, parse it and use it as an integer value for the port number. And then we're going to create the server socket, same as before, server socket, the socket is equal to new socket with the port number. This is identical code as we saw. In fact, the two examples are meant to be as similar as possible. And we're going to listen to it. And then we are going to listen for the next incoming request, and we're going to accept it. So socket, client socket is equal to the socket, accept to the method to receive it. Then we're going to get the remote socket address and then get the port number from the client. And then we have client connection. We're going to set up a client connection. So for the new connection, we spin off of the thread. We spin off a thread. Here's where the thread comes into play. Yeah, this is going to be a multi-threaded server. To handle the communication specific for the stream for each one of the sockets that we have connected clients to. So note that the connection will require its own client socket. This is where the inefficiency comes into place. We have multiple threads for each one of the clients requiring its own dedicated socket. So the client connection is going to be equal to the new client is equal to new client connection, client socket, and then connection counter plus plus, because we're keeping track. So each one of the clients gets its own integer value. So it's going to be client number 1, client number 2, client number 3. And if we wanted to, we could actually at any one moment query the server from the server perspective and see how many clients do we have connected. In the UDP example, we have no idea how many clients. We don't keep track of that stuff. So here is our subclass in here, our class in here, our client connection class, which is separated out into a separate abstraction. It's a separate object, actually. It's a separate class. And this is where the differences are going to come into. So this is pretty much the same as what we saw in the UDP. We still have to use a port. We still have to use a socket. But here's the establishment now of the TCP part of the client connection. So we have our data input stream instead of datagram. And so now we have an input stream. We also have a data output stream. We still have the socket, and we still have the integer identifier, which is going to be associated with each one of our clients. So in terms of our constructor here, we're going to just create instances of the counter and instance of the identifier, instance of the socket here in terms of the client socket. And then we're going to do our try and catch, and we're going to basically, going to set the values of it. So the client socket is going to be the incoming client socket, incoming client identifier, and then we're going to display the vital statistics that come in. And then we're going to hook up the plumbing. Here's the plumbing part. The plumbing part is to connect the stream. So the in is going to be equal to the new data input stream for the client socket for the get input stream for this method to get the input stream of the client socket and have it equal to the object for the data input stream, and then the data output stream is going to be the get output stream. That's going back out to the client. Mark the threads as startable. This dot start. This is just kind of the syntax you're going to need to do for those two threads. Yeah. Thread programming in Java. This is basically follows traditional thread programming techniques, but the threads are the abstraction of the socket connections. And then we have our void run here, which is going to need to override the method from the thread in order to have the threads do anything useful in terms of getting that data from the sockets, the stream data. So we're going to read in the message and we're going to put it into a string. This is the best part. Yeah, this is what I was saying before. It's easier because there's no conversion from the data, from the byte array to the string. And this is the same string as we get with the string class. This is a string class, a string the data, which is going to be in read it from the stream. So it's going to read this stream and put it into a string, and this is going to be the same for the write for the output stream that actually occurs, so that we can send it, and we're just going to print it to the screen here actually. The rest of it's the same. We have the catches on all of the exceptions that we could possibly run into, and then finally on the socket, close the socket, close the connection, and we're ready to go, essentially. So what I'm going to do is kind of demo the server and then just do the same thing I did with the UDP, go back and take a look at the code for the client. So let me get this guy started. Maybe I was on the desktop already. S code. Let's see, John. Let's see. TCP Server. This one's a shorter name. There we go. And, there we go. That's what I wanted to do. So we're going to go Java TCP Server 8888. How about that? I'm sure there's nothing on that one. I haven't rebooted my computer, so 777 is probably going to be, may not have a problem, but this one's going to say now it's listening on port 8888. So let's go ahead and look at the TCP client for a moment. Same as before. Same two packages for the imports. What do we got here? We've got the mainstream. This one's going to be the same format here. Actually, I would put this down here. It will help for me because I'm going to have to do this in a few minutes. Server name, which is going to be localhost, and we've already gone through that. The port and the message. What is this going to do? This is going to take the internet address of the host, and the host is going to be the get by name from internet address object. from the argument that we're taking, and that's our local host. And so we get the local host, and now we're going to have the port. That's also going to be the port that we're listening, excuse me, that the server is listening on, which is the 8888. And we're going to say the socket is going to be equal to the new socket with the local host in the 8888. So to basically create the socket. Here's the difference here. Now we're going to hook up the plumbing, and here's the hook up the plumbing. We're going to have to set the data stream, so no more datagrams anymore. Instead we're using data input stream in, and that's going to be equal to the data input stream method from the input stream that's going to go from the socket. And then we have the output stream. Actually, it's the same as the server. This is the same code as the server. It's just the logic is switched around. So this one sends, it doesn't wait on a port. It doesn't wait and listen. So we're going to send a message. We do the same thing as before. Here's the destination server. We can send the string as is, and part of the message it gets automatically converted to the stream in terms of the passing of the message. And it's going to be argument number 2, which is what we're sending on the command line arguments. And then we're going to print it to the screen, and we're going to set the timeout. Here's the interesting part. When we send it, it waits. So we should notice a little bit of a delay. If we hung the server, it would wait until 5,000 milliseconds, or whatever that ratio is actually, whatever the measurement's actually in. I think it's milliseconds. It is milliseconds, actually. If I read the comment, I might know milliseconds. Otherwise, it sits there and hangs. So imagine we have something like this built in the RMI, actually, which is why, as I was saying before, depending upon the latency, we might notice it because there is a timeout. It is TCP oriented. It's built on top of it. So we do have to actually kind of take that into consideration. But it's not that big of a delay. We can always put a timeout in there. You can put a timeout in RMI as well. You can set the timeout so that your client doesn't hang there waiting for a response back. So it's going to initialize the connection. So TCP is actually it's a three-form connection. It's a send, and then it's a receive and acknowledgement. So you send a message, you receive an acknowledgement, and then you send a confirmation of the acknowledgement so that the server knows that the client's connected, the client knows that the server's connected. And it's a 3-message passing exchange, actually. And it's 4 to disconnect, but it's 3 to connect. Just kind of interesting. You don't really have to know that. If you take a networking course, you'll see all of the message exchange that occurs between the 3, the acknowledgement, the send, and the receive. But long story short, we are waiting for the server. We don't just assume that the server is going to send something back. In fact, on the UDP example that I gave you a few minutes ago, I could have stalled the server a little bit, and the client could have just it would have received eventually through that port. But it may not have received it the same order as the other client got it or something. We can definitely, the order in which the messages are coming back is not patterned. This is patterned, yeah. The patterning of this slows it down, actually, but it makes it more reliable, and it makes for a more connected feel because it is connected. So the rest of this code is pretty much the same. We're going to catch an exception, catch a socket exception, end of file for the stream. A little bit more, I should say, versus the UDP. Code is a little bit bigger. The finally here is always going to clean up after yourself. You're going to close the socket connection if it's not null. The socket has open, so it's going to be closed. And close the socket connection. And that's the rest of the code there. So it's pretty not too bad. So what I'm going to do now is open up a new. Actually, I don't need this anymore either. Open up a new. Oops, I don't need Xcode. I want this one. I want terminal. Open up a new shell. You don't actually have to do that. The client's going to send it on its own. But yes, each client's going to have to come from a separate window. Is that what you?
The port is same?
No, different. I'll show you. I'll show you. I think it actually prints out the information. But let's see. When the server, the server's waiting on port 888. When I send this message from this client, it's going to be on a different port coming in.
The client port. You mean the client port?
The client ports are always going to be different. The server, we only have one server on one server port. We don't have no more.
It is always use the same port.
It's also going to be different as well. Yeah. let's see. I believe all of the port information is going to be printed out on the client on this example. If I was remembering what those print screens were, the printouts, system
What
outs
is
were.
the client port number?
Well, let's see. Actually, I think I believe that this one actually might do it for us. But let's just take a look. If not, I could put some systems out in there, and we can see what the ports are for each one of the clients. But you probably could figure that out on your own as well. Let's see, just Java C. Yeah, what are we doing here? TCP TCP Client. Java. Java. How many times I have typed in Java? So this one here is going to be client number 1, and we're going to go Java TCP Client, and I'm going to connect to localhost, and it's going to be on 8888. Yeah, so I'm just going to make this a little bit bigger so I can put it all on the same screen here. Hello. Alright, there's down here on the bottom actually. So 8888, and we'll send it hello from A, and press return. So this one says that it has successfully acquired the port for the server. Good. And that the destination localhost was on port 888. Sent the message hello from A. Received a response back from the address localhost 888. The reply was received it. The socket was open, so it's now being closed. It's opening and closing it, so now we're back at a prompt here. So I can run it again if I wanted to. Over here, we're keeping track of, we're listening to it, and we have received a connection. And this is the port number. If I believe the syntax correct, we can take it from here actually. We have the colon after the address with the port, and the colon after the address with the port would be port number 49610. So it is the port. It's the same port, yeah. So we can actually, because this one opens the port, closes the port, opens the closes the port. If I do this and say hello B as an example, we see up here it used a different port. Yes, because it has a thread that's attached to it. Yeah, so it's going to give us a new ports for each one of the connected clients because it doesn't know. It has no idea that this is from the same box. So if I opened up a new one, in fact I don't even have to, but if I opened up a new shell and did the same thing, I'm always going to get a different port that comes through on it. The way that this is designed, it's not going to reuse the port. Otherwise it can't keep track of the client. Yeah. It's state oriented. So here, this first message was on this port here. The second message came in on this port here where it has received from B. And here we have thread 0 and we have thread 1. We have two threads that are associated with each one of the transactions. So closed a socket for thread 0. Yeah, so here we have thread 0, thread 1. If we go again and say C, and we come back up here, now we see thread 2. So now we close the socket for thread 2, thread 1, thread 2. If we had an open socket, this one, our client is disconnecting, by the way. Because otherwise, I probably would take my computer down and ruin my recording eventually. I'm closing the socket so I can utilize my resources a little bit more efficiently. If you wanted to, you can leave, the client could leave that socket communication open. If it did, I would have right now 3 simultaneous threads going on. The server is keeping track of the threads, but it doesn't know because the client disconnected. Yeah. So every time I send it again, it's always going to, like if I go here with D, it's going to again, now we're up to 3. Now we had 3 sockets connections going on. So each one of these clients that connected to it was as if it was a brand new client. And if, let's say for example, we had more to do than just send and receive a message, it could be keeping a constant connection without this. I have another example actually that keeps the port open. Only problem is it has a tendency to crash my computer. And think about it. I got many different threads. There's a lot of processing going on. And if I have some stuff running in the background and stuff like that, it's going to make it run too slowly for me. I'm going to be impatient with it. So, do we understand the concept of connection versus connectionless? Connection-oriented versus connectionless. We know that we have a stream that goes on here instead of datagrams. because we're using the stream input and output versus the datagram of the send and the receive of the packets. So, excellent example. If you're still unfamiliar with it, I highly recommend downloading that source code file and taking a look at it. Just taking a quick look to see, nope, these are all going to be RMI examples. So I'm going to exit out of these windows so I can sort of conserve my resources, so to speak. The way you kill the server, actually I recommend killing the server, is just Control-C. Yeah, there's no graceful way of killing the server in those two programs. So. If you close the DOS prompt in Windows or in actually in Windows, if you close that DOS prompt shell, it's going to close you're going to lose everything, and it's going to close everything for you. On a MacBook, I believe the terminal one is going to keep that process running because it's a shell to the underlying BSD system, and it's not a separate program like DOS running on. I believe it's not going to kill it automatically. It's better to kill it before you terminate it or exit from the connection. So, or reboot your computer, better yet. So. Alright, so we went through that drill for kind of a purpose, actually, to help you with the assignments, to show you the underlying communication, but also in terms of comparison and contrast to what we're looking at next in terms of the Java EE components, and that's the, lo and behold, remote method invocation. There's another example, ask the register, ask the student, that's in the 3 parts that I'm going to explain to you, and then I'm going to wait probably until the next, because you already have 2 projects and 6 assignments you can possibly complete right at this point, or actually 4 assignments probably that you can do between now and our next class meeting, which is going to be in a month. So that's more than enough work for you. So next time when we meet on the second weekend session, we will look at the source code examples, but I want to explain RMI today. And then I'm going to finish off with, there's another lecture after this that's going to get into internetworking. So kind of finish up the networking components for this weekend. And the next time we'll talk about servlets, Java beans, and we'll see those RMI examples put into use. It's sort of the roadmap for the rest of the course here. So RMI provides a communication channel between the distributed objects by means of remote method invocation. So we've been sending and receiving messages via datagram packets or via streams over threads, which is a lower level abstraction. Take the threads now, keep the thread concept with TCP, and create objects and put the objects on a remote computer. Come up with an object manager who keeps track of the instances of those objects, and then now through the threads you're going to invoke methods on the objects, and you get remote method invocation, which is essentially what's going on in terms of, it's a simplified explanation of what it is. There's a lot more to the technology than that. But RMI, the objects can receive remote method invocations. Well, what is a method invocation? Is to run a method on an object. So my connection dot something or other, the dot something or other is the method that we're running on that object. So we're calling remote objects, which means they're not on the local computer, they're on a server. So it's just like the thread, but instead of sending a stream, we're sending a method invocation. Yeah, directly instead of the stream. So now we're taking it up even a step further. Instead of going with datagrams to streams, method invocation is what we're sending back and forth, is what we're doing. They implement a method for a remote interface. And this is where it starts getting, for most students, a little complicated, because then now we have to take all that we just looked at a few minutes ago with TCP and UDP, put it in an object-oriented world, and let's talk about public, private, protected interfaces and views, access protocols for methods on objects and data on objects. And then we start looking at how it fits into Java. So this is an extension on the local method invocation that allows the object living in one process, so we still have the process state going on, to invoke methods of objects living in other processes. So what are we looking at? We have RMI at this level here, and this is a kind of a review. We've seen this earlier today. In terms of the layered approach to the operating system, the request-reply protocols, the external data representation, and now we have the RMI that's kind of right on top of that in terms of the middleware layers. That's going to add the level of abstraction that we need. So the interfaces, this is an interesting new concept perhaps. The interface specifies the procedures and the variables that can be accessed from other modules. What does that mean? Well, the interface in a regular JVM environment is your public, private, and protected. Or your access methods is your interface. Your public interface, we create classes in the normal Java environment. We create classes, and we have what's called a driver program. And the driver program is main, and main is the public interface to those objects, and we make instances of those objects in main, and that's our program. So the interface in an RMI is the application communication, and it's the interface to the objects that are being served up by the RMI engine. I'm going to call it an engine. Server, it's really a server technology that's serving up the interface to those modules. We can't run everything. We can only run what's being given to us. Just the same way as we can say something is private, and in the main driver program we can only get to the public interface of that object. We have the same kind of protection that goes on in RMI, only certain methods are supposed to be invoked this way. There's the only ones that are going to be available. So the modules are implemented so as to hide all of the information about them except that which is available through its interface, which is what that second bullet point is referring to. So as long as the interface doesn't change, and it shouldn't change, and this is the same concept that you're supposed to be doing with your regular applications that you're writing. You're never supposed to change the public interface. Those are the public methods that are part of the object. Then without affecting any of the modules themselves, they can live there forever. And you're building essentially an environment that's going to grow with method invocations that can be from any object that has a consistent public interface to it. So in the distributed program, the modules can run in separate processes, which they do. Cannot access the variables in a module in another process. Not direct variable access either. So you can't actually see in Java they actually let you break the rules, with public interfaces, and you just put public on everything, and you can out there in main you can change the data, you can change everything you want. Can't do that in RMI actually. It's blocked. It's for a reason actually. You've wrecked the integrity of the object if another object can go in and check. If another object can go in and change the data members, so it's meant to be access to the public method invocation, or method interface. And the other point that was actually kind of an interesting one was kind of two very important small points at the bottom of that slide. Modules, objects that exist in one thread can't communicate with objects in another thread. Just like those TCP clients that are in an island of their own, they have their same thing true for these remote objects. There's no inter-thread object invocation. It's client to server through thread abstraction of modules, objects that are available to certain threads, which is interesting. So other differences, parameter and we'll see that in an example. Actually, I'm going to show that to you today in a PowerPoint example. We'll see the source code stuff next weekend, and next time we meet. Here's some other important differences. The parameter passing mechanism. So the call by value versus call by reference, i.e. call by value, call by reference, used in the local procedure calls do not work in distributed systems. There is no call by value, call by method. It's kind of a moop. What do they call it? Not a point, not an issue. Uses input and output parameters that are passed between processes. It follows the same concept as the TCP IP that we just looked at. It's the stream. It's the input and output streams that are the parameter passing that end up being passed to those methods as the parameters. There's no such thing as call by reference, call by value in this particular case. So because a value that is stored on the client, if you think about the logic for a second, a value that's stored on the client's computer, how's it going to get changed by reference on a remote computer? It's just way too complicated to begin with. It's not going to happen. So we can't take advantage of some of those things that we normally would see in terms of being able to pass an instance of an object to another object and have that object change and bring the object back and do some interesting things by reference with that object. So Pointers in one process are not valid in other processes as well on the remote computer, which is basically the same concept of there being no pass by reference, call by reference, because we can't use pointers actually in this environment. We don't use pointers in Java anyway, but object references are sort of like pointers if you think about it. No pointer passing is allowed, so that's another big difference. What does this thing look like? Here it is. Here is the local and the remote invocations. Compare this to the sockets that we looked at in the other examples before lunch with the clients and the servers. We don't really have this thing called client server, but we do. This is really the client over here. And this is the server sort of over here. But it's distributed, so we don't have client server. We have invocations, invocations, invocations. So this would be the remote part of it, which means A is making an invocation over here to B, the local invocation over here to C, local to D, local to E, and maybe another local. Maybe E is making a local over here to F, which is going to be on another server or another platform, another object, somewhere over. So we don't have that strict client server, because technically then this would be a client to this server over here. So we don't really speak of it in terms of the client server terminology anymore. This really becomes more the distributed definition that we're thinking about. And when we say invocation, it's we're invoking methods, essentially running functionality on those concepts. So how are we going to make all this stuff work? Well, we have a few more components to think about in terms of, we're no longer thinking in terms of sockets or ports or streams or datagrams. So we provide, the RMI provides the adapter for effectively hiding the network from us. So this is the network, these are all hidden from us. Instead allows us to simply look up functionality that we want, regardless of where it actually exists, and use it as if it was locally available. So the level of complexity is definitely increases once we decide to distribute the objects in the Java system. Assuming we start with two Java programs. One is the caller and the other. One is calling the other. Two programs are calling each other. We're going to put them on two remote computers. We now introduce the following elements that come into play. We actually create the interface as a separate component. So the interface, and the interface that explicitly states what functionality is remotely available. If it's not in the interface, it's not available. Instead of the interface actually being part of the object, we can have different interfaces, and doesn't affect the functionality of the object. We don't recompile the object. The object actually kind of stays the same. Think about the concept, it's a lot more flexible. But we have to remember we have to create this interface. Put this interface somewhere. A server has to exist, and the server provides the access to the remote objects. So we still have this server that's serving up the object, because we have to have some, and a server can be a client as well, but we have to have that server concept. And then we have the registry, so the RMI Registry, that links up the request from the client to the remote object. And the registry, think of it more along the lines of a lookup service. Not like a Windows registry, but like a domain name registry maybe. Kind of similar, more like a hybrid between the two of them, I guess. There's more information in the registry versus just locations. It's not like a domain name service. Actually, Java has one of those. We'll get into that. Gname, yeah. But we'll get into that next time. So here's an overview of the RMI interfaces and the classes. We have the interfaces that are defining, and here are the classes. We have the remote object with the remote server, with the activatable, unicast and remote objects, extensions, and we have IO exception, remote exception, because we have, and this is the best part about the entire concept here, is we have tons of built-in IO exception and remote exception. What if the object's not available? What if the object's busy? What if the object times out? Stuff like that. So we start with two Java classes that are not RMI enabled, and we're going to adapt them to operate with RMI, so you can see exactly what is needed. This is actually in, all these files are actually in the scode.zip file that you saw in the last lecture. So in there we have the non-RMI program, and then we're going to convert it, and I'll go through the slides for it, but I'll save the implementation for it for next time, otherwise we're never going to end today. Let's imagine now that we're going to devise an automatic registration process. This is going to be a student registration process, the same example that was used earlier. And it's not knowing which classes for which we want to register. We're going to tell it if you are registered or if the class is full. So a student's going to go in and check the objects to see if they are registered or if the class is full. So here we have asktheregister.java. This is not an RMI program. This is a non-RMI program. This is just a regular old program. So ask the register, it's got to string the class that they're interested in checking out, and then we have the object implementation here where the class is in which class, and you're going to send it, ask the register, if Java EE, if I'm registered in Java EE, get register status is going to come out and say, are you in there, whatever the class name is, you're registered. Otherwise, it's going to say, no, there are no positions available to be registered. So this is kind of like you're a student and you're trying to enroll in a class. So you're either going to get in or you're just going to be full, one of the others. So the class, here the class includes the words here, case sensitive, when the class must have some spots open, otherwise it's going to be full. So it's kind of an easy, this would be the client, ask the register would be the client. So here's the local application to invoke the functionality of a local student, and this would be the local application because this would be like the, the main, the driver. So in order to work, both classes must need to be in the directory within the class path, obviously. So what is a local student? It's got a main in here, so the driver program. It's going to say local student running, and it's going to make an instance of ask the register here, ask the register current status. It's going to send the current status to the register, to say whether or not. And it's not really sending it anywhere. It's a local program. It's going to find out if there is anybody in there or not. These files are actually in that downloaded. If you basically run it, you're going to get this here. It's going to say, status is this. You're registered, you're not registered. So by passing the argument CS483, ask register service, concludes that the student is registered because it was hard-coded in here actually. Code is hard-coded to see. If you're sending it this, it's going to come back with this. If not, it's going to come back with that. So it's kind of a stupid program. But, it's kind of, I shouldn't say stupid, but it's kind of simple. It's like hello world of RMI. So let's take the example and turn it into a server RMI example where the local object is going to call the same ask the register object, but instead of asking it on the same computer, it's going to ask it remotely. And so we're going to turn it into an RMI ask the register. So let's see, we're going to move ask the register. So I'm going to kind of go through this in a lot of detail because it's sort of what I want to give you is the format for this, kind of the composure of how this application is put together. So we're going to start with the server. And so we now seek to move ask the register service, which is the object that main driver program actually invoked. And it was a local invocation. We're going to make it now a remote invocation. So we're going to make that object into the server object. So we're going to make it the service, we're going to move it over to a remote server so that it can be asked by multiple locations within the university by multiple driver programs, essentially. So the first step is to decide what functionality should be made available. Currently, ask the register class has 2 data members, a constructor, and a ask the register status. It's hard set for a class number. Constructor will not be available remotely. Think of the concept. You're not making any instances of any objects. Instead, you're going to call methods on objects that already exist. There's no constructor in a remote object. Although the programming is identical, the concepts are slightly different in terms of what you're doing. So currently, the constructor will not be available remotely. And so you need to create an alternative method to set the location. So it's almost like going backwards. It's like people who never liked to write constructors, you're in luck. You don't have to write any more constructors. Instead, you make methods to set and get information regarding those data members. So there's 2 functions. You can set a class. So we can do a set class. and a get register status that will be available via the remote invocation, and we can now create an interface detailing these decisions. So we have these two methods that we're going to make available to this object, and one of them is going to be the original functionality to get the status. The other one's going to be a replacement for the constructor, which is going to be set class. So you need to enhance the object ask the register so that it can be remotely used. It's the same code as before. Actually, we're just going to make modifications to the Java file. So in terms of the example, here's the sequence diagram of what's going on, and this is how the registry actually fits into the picture. In our UDP TCP, we had a client and a server. Now we have this guy in the middle. He's the middleman. He's the registry. So the client determines the remote object location. It will always communicate with the registry to get the client location. And then the registry comes back to the client and says returns the object location. Once the object location is found, then you invoke the remote object over here on the server, and then the functionality is executed back to the client. So there's that one step with the registry first. So if you don't create the registry, your program will never work. If you have the registry out of the path, not registered correctly, the program's not going to work. So hardest part with RMI is kind of like JDBC, is getting the driver visible. Here it's getting the registry set correctly, and the interface, which we haven't talked about yet, getting that one set correctly as well. And speaking of the interface, here we go. Ask the register interface. We know we have two methods that we're going to invoke remotely. One of them is a replacement for the constructor, the other one is the functionality of getting the status. So here we go. We have the set class, which is going to be our replacement for the constructor, and then the get register status. We don't have, this is like function prototypes. This is like the .h file in C++. It's a header. Function method prototypes, I should say. It's called an interface. It's the same interface that we get with interface classes, or interfaces that we can create in object orientation. This is why it's helpful to have had taken the object-oriented programming in Java course before this class, because we talked about interfaces and we made interfaces. So classes implement interfaces. So that's what we're going to do in that remote object class. We're going to implement this interface, and the interface is going to give us the available public access to those methods. So remember, an interface is a contract that the class can choose to implement, so there's no actual code in the interface itself. Yeah. This is just like any other interface that you would have created so far if you've taken the object-oriented programming course. So we have to create a new version of the ask the register to make it a remote object. So we're going to see the ask the register remote. This is also available in the S-code file. We have to add two things to it at the top. We have to add the import for the RMI and also for the RMI server package, because we're creating a server object. So the package is to enable the remote invocation capability. Also, we need to inherit from unicast remote object as well. So in terms of the parent class, because we're no longer inheriting from object. We are now creating an object as the main object that we're normally don't need to actually include, but we're making a remote object, which is a slightly different type of object. So we're no longer inheriting from the regular line. So the object means that the single instance as opposed to a instance per request. The only thing different is that you can only make one instance of this object. It's impossible to make multiple instances of it. Regular objects, you can make as many instances as you want. As the remote registry remote object, as for the remote register remote object, it will be enabled to be called remotely instead of locally. If you don't do this one step, you end up with an object that it works fine, but when you start up the server, it doesn't get no instance is actually created. So provide new methods to outlined in the interface, the set class and the two methods that we're going to use. Add an additional constructor that takes no arguments and sets the private the class variable. So what we need to do is we have we put a constructor in there. We can't call it, but the object itself, believe it or not, is actually going to be initialized with it. We just can't call the constructor when we make an instance of that object. But the object itself can call its own constructor.
This singleton class.
Say that one more time?
Singleton class.
Yeah, singleton class. So the RMI registry. The client wishes to use the remote object will need to know exactly where it is located. So the RMI registry actually is the phone book that we're going to look it up with. So coordinating phone book that records every object's name and address, publishes the object's information in a well-known location. So we start the registry by typing in RMI registry.exe on a Windows machine. One of the reasons why I'm not going to demo it is because I don't have this installed on my Windows partition, and I can't run it from my Mac partition. So next time we'll see it run live, but these are the steps. You can try this out on your own and see how far you get. If you most likely will be successful. I have some screenshots actually of it running in the PowerPoint slide. So in the same directory, not to say that it won't run, it will run, I just don't have it installed. It probably, I've never actually tried it on my Mac partition, but I suspect that it will run just fine. It's going to be a different file though. Long story short, not installed. Okay, so in the same directory as the other executable files, you're starting the registry. It's a command that you're going to run. It's going to load something in the service in the background that's going to run. It can be run by itself or as a background process. And we will run it as in an own command window, this particular example. If I have it, I might actually have it. You know, do you guys want to see it? Yeah, let me see. There's no guarantees that it's actually going to work, but let's see. Let's see if I even have it. We can kind of. It has not been tested, but I will need to load a Windows. I don't have the EE version installed on my Mac partition, but I believe I do have it installed because I ran the RMI yesterday on it. No, I ran the JDBC yesterday on it, but actually JDBC doesn't require it either. But I believe I have the JVM 1.7 on there. So I should, let's see if this works. Actually, it's a good test. And I have the code actually, I've downloaded it already as well. So it just means I have to start up a Windows icon here, Windows desktop. Give that a few minutes to load. I'll know off the bat if I type in RMI registry, whether that runs or not. Then I'm going to know whether or not I'm going to be able to demo this today. And I'll need to copy the files in, it looks like, as well in this partition. But let's take a quick look here. Make this a little bit bigger so you can see what I'm doing. It does load a lot of stuff in the background, and this is running in a Windows partition on a VM. This is running on a virtual machine. So I suspect it will come back in a few minutes. Have not tested it, however, so if I can't get it to run, it should come back with something. It should come back with something. It's not coming back with something. Well, interesting. I'll just leave that alone for a few minutes. I'll continue with the example. We'll come back to that. Maybe I can just make this. That's probably big enough for you guys to see. I can zoom in a little bit here. Okay, so the registry starts off with an empty directory. So it has no way of actually invoking any objects because it's empty. So its only one job is to provide the location for all of the programs that it asks, like a directory assistance. Actually, I'm not quite sure it does come back with something. It might actually be loaded. So we now need to, we will now need a Java program similar to the TCP server that's going to accept requests from the remote objects. Actually, you know what? Now I'm curious. I might actually have it. Let's see. I'm going to try it on both here. This would be a good experiment. Because it did not come back with an error message, I suspect that it is loading, or may be in the process of loading. So, given how much is running on this computer right now. So let's talk about the server for a few minutes. Make this a little bit bigger so you can kind of see it. So we now need the program itself. We're going to have to modify the program. I have written the code. It's actually in scode.zip, and I'll pull that out in a few minutes to show you the actual source code. So the servers must also communicate with the RMI registry that exists so clients can find it. And oops, I'm not in PowerPoint presentation mode, so I have to manually switch it. Oops. Okay, hold on one second. Too lazy to switch back to the PowerPoint part. Ask the register server.java. Let's just look at it this way here. I believe that might actually be running. Ask the register remote. I know I haven't asked the register server. Ask the register server.java. Here we go. Here's our ask the register server.java, which is going to be the same as the slide, but this is the actual code. So what do we got going on here? It's going to, oh good, I've got localhost in here too, good. So it's going to load up the module itself, and this is the module, this is the method, the object that's going to serve up the status message. So it's going to print out that the ask the register server is ready, and it's going to do nothing more than establish the server object component that's going to be connected to it. So let's leave that up temporarily. And that is this code here. I should be able to, there we go. I can flip. There we go. So I've got a man-made PowerPoint going on here. Except for we got, that is the code I just showed you a few minutes ago without all of the squiggly lines. So the RMI server example here, this seems to be a very small amount of code actually, compared to the previous UDP one that we looked at. The magic happens in the single line right here. The naming.bind, it's going to bind the name to the local host ask the register it's going to make a new object here of ask the register remotes in terms of what the server is doing, and that was actually in the code I just showed you a few minutes ago. So the rebind command is what actually informs the when the method, when the object instantiates, makes itself the rebind, tells the registry that it's there. So it's the communication channel between the rebind method is the communication channel between the object and the registry. So it informs the RMI registry that the remote object is now available for remote invocations. So in fact, the RMI registry that I just typed in on the command DOS and also on the terminal prompt is the middleware. If you think about it, it's the registry keeping the objects together. So it's pretty much what's making the whole thing work. So the first argument is the remote object's name and the directory, as well as the RMI registry that will be informed. In our example, we're contacting the registry on the local server, local host, the same thing we used in the previous examples for UDP and TCP. If the registry has a port other than the default, and the default is 1098, we haven't used that one in any one of the examples, so that should be open. This could be specified by placing a colon next to the new port, just the same way as we saw in terms of the port ID and the host and the port in terms of the syntax with a colon between the two. We saw in UDP and TCP. So the identifier after the server is the name of the object that we will be listed as the server. So the directory name does not have to be the same as the actual remote name. And I believe we have a rebind in here. Go back to Xcode. And here's our rebind command. This is what the slide is referring to in our particular case. Our object is ask the registrar, and it's on localhost. And we're going to assume we're going to use the local. We're going to use that port. I believe the port should be open. So I'm just going to create a new instance of this local ask the register remotes. This is good. Okay. Big manual PowerPoint. Okay, good. So let's see if I can get to the next slide. Here we go. So we also have the RMI server in terms of the second argument that has created the actual remote object itself that will accept the request from the clients. So because we're unsure of the location of the clients, we can invoke a no argument version of the constructor which will set the internal location to an empty string, and then we can require the client to specify the actual location of it later. Most important point too is to look at is our non-RMI setup. In the previous example, each instance of the client application and the local student, which we didn't actually go through, but he saw the code for it. Created its own instance. So the main program created its own instance of the object. Well, we don't have to create our own instance anymore. So we're not going to create an own instance of it. Instead, the RMI version, we have one single instance of the Ask the Register class that we're going to be using through the RMI Registry. So the RMI Registry essentially just keeps track of that instance of the object once it's created. So let's see if I can get that service object created, the server object created. So before we can run the server, we need to generate a stub class and the remote object that will be used by the server. So we can use RMIC utility to do this. And I'm going to open up a separate terminal window. I'm actually going to try this on the, I don't know if it's going to work, but I'm going to try it on my Mac partition. And if it doesn't work, I'll go back to the Windows. So I've got two, whoa, PowerPoint is saving the recovery file. Let's just see what happened here. Not sure what happened. I still got PowerPoint up. Okay, good. Anyway, I'm going to try. I've got two options here, so let's see which one is going to work. But the syntax that I'm going to follow here, I'm not quite sure what happened to PowerPoint, but probably taxed with memory. The server does not exist. RMI Registry still has an open reference to it, so will be continuously available to any incoming requests that might reside. So now we have a server. We will run it from a command line, and we're going to do this. We're going to type in, I'm going to type in RMIC, and then ask the register remote after I compile it. So let me actually go through and compile all of those things so I have the objects created. I'm going back to my terminal prompt, and I'm going to notice that I'm going to leave this window alone because I'm going to hope that it is actually loaded. And I'm going to open up a new shell. So I still have the registry running, by the way. I'm opening up a new shell. Because I did not prepare this ahead of time, I have to go in and compile everything. So let's see. I'm just going to do a Java C start.java. What do we got going? Invalid. There's no space, you're right. That's interesting that it ran TCP Client class. It's interesting. Error message. Alright, so RMIC. Let's see if RMIC works. It does work. Haha. I might actually have this loaded here, which is great. RMIC. What is it? Ask the registry server. Now you're asking me to spell. It's this guy right here. Ask the registrar. Did I spell that right? Server. Error. Class Aster does not implement an interface that extends RMI remote. Only remote objects. I don't believe that's the right one. It's the remote. Let's go back and take a look at the name of that one. I have so many different versions of the... hold on one second. Ask register remote is the one. Yeah. That's okay. This is great. Ask the register remote is the one we need. So now we can see it wasn't set up. It didn't have a rebind in it. It didn't actually contain the right code. So as a troubleshooting technique, you'd go to yourself, maybe I don't have the right one. So it's ask the register. That was the original ask the register server, actually. So now we're going to use the same one, but it's ask register remote. Perfect. That's what we want. We want it to come back. No error message. This has saved me from having to install. I didn't know if I had it installed or not, actually. So we have, we've got the register running in a separate terminal window. Make sure to use separate windows for these, by the way. You don't want to use the same one because that's going to run. We have distributed system here. These would be different computers that we'd be having all of this stuff running on, by the way. And it doesn't mean that just because you have the register running on the computer, it can't be the same computer as well. It's very common to have them both actually on the same. The registry is just going to be the lookup system. So we have now, I didn't get ask the register servers ready, however, which is kind of, okay. Might be a little disconcerting. May or may not be running. It could be that I have taken out that prompt. I don't know. We'll see what happens. If not, I'm going to try it on the Windows side. See what happens. So now we're going to create the client that accesses the Ask the Register remote object. And there's two critical lines that exist in the client, and this is going to be called, just get the client name. It's Ask the Register interface. Let's take a look here. Got my list of classes here. Interface, I believe it's going to be Ask the Register interface. But we'll see. There we go, that's what I wanted. Let's go back to the PowerPoint for a second. So let's see. What we're going to do is essentially two critical lines of code to actually kind of pay attention to is the Ask the Register. The naming lookup, it's going to look from the remote server, Ask the Register. So looking for the Ask the Register object that is obtained in terms of the register, and it's going to essentially print out the status. So the first one we're going to do is first use the same class naming that the server did to connect to the RMI registry. So in this particular case, we're asking the register for the location of the remote object, and it should be known as Ask the Register in our particular example. So this is also the return is the reference to the interface we initially created. So this interface hides the fact that there is no code locally, but simply provides a stub. So it creates the stub for us that we're going to call the remote object to perform the actual work once the registry finds it. Because remember, we always talk to the registry first, and the registry goes back and tells us the location of the object, and then we connect to the object. So essentially, it's a two-phased kind of approach. So the second line uses the results object reference as if it were local, which was our original intent. So the second line here is the Ask the Register for the actual location. Oops. So now we're going to see the results by running the client. Let's take a look at here. Java local student client. Local host is what we're going to use there. And we'll pass it CS 483. And we'll hold our breaths on this one. Let's see, local student client. Local student client. So remember that one. Local student client. And, open up a new window. Actually, I'm going to minimize this guy. Registry is still running. You know what? I'm a little less concerned about that one, but let's see. Let's see. To S code. Okay. Local student. Forgot already. Local student client. Local capital S probably. Student client. Local host. Oh. Locals. Okay, thank you. It was a local host plus CS something, 483. 483. Whoops. Aha. Local student running, called with two parameters. Remote server localhost class 483. Local student unexpectedly quit. Exception. Ask the register. Local student failed. So the register is running. We have an issue with the Ask the Register object stub here. Did I?
No, we haven't done.
No? Say that one more time. We are communicating. The registry is actually running, which is good.
Interface we have.
I may not have compiled the interface. No. Let's take one look here. Let's just make sure that I'm running the right. Let's just check one more thing here. Local student client. Local student running, called with two parameters. I believe I may have run the wrong remote object because I should have received back Ask the Register server is ready. I think I may have been running the wrong one. I'm supposed to be running Ask the Register server. I did not load asked the register server. Okay, very good question. Very good example for what I did wrong, actually. I loaded the stub. I didn't load the server. Server's not running. So the register found the stub, didn't find the object because the object was never started. So I actually have to load, and what I did was I failed to actually notice that there's two commands being run on this window. I ran the interface, but I didn't make the instance of the object. So I have to type in Java ask the register server. So I'm going to do that, and I can probably do that in the same window as the ask the register remote. So I'm going to do that to follow my example here. Great way of troubleshooting stuff, by the way, is just to kind of go through your steps, just as what I've been doing actually. The interface, when it gets loaded, is just being registered with the register. So I can type in right here, Java space ask the load the object, load the remote object that I'm going to ask for, registrar, I believe, oh no, server. And do I need to give it parameters? No, maybe I ask the register marshalling, hold on one second. Server unexpectedly quit. Occurred in server thread. And marshalling error. Need exception is class not found exception. See if I loaded the right RMIC. Well, did it register correctly? I'm going to try something else actually right here. Let's just make sure I'm loading the right file here. Ask the register server. I'm gonna re-register it. I'm gonna go run through the steps one more time because it may have the registry may actually be faulty because it didn't actually. I ran this without. I called the object without it being there. It's already come back with an error message. So I'm gonna repeat my steps essentially and run them both again, just on the slight chance. Actually, it didn't come back though, which is kind of interesting. It didn't come. It actually is loaded. The server is loaded, so I'm actually going to try something real quick before I do that again. Otherwise, I will try the steps over again and just load it fresh. So the registry actually has knowledge of the object in existence. Okay, so we are having issues with that one, so I'm going to leave that one alone. Control C out of this one, because it actually did load, which is kind of interesting. Oops. Ah, you're right. Server. Otherwise, I do have that Windows partition I could try it on. I did this once before. It's the other one. I'm loading the wrong one. It's RMIC. This one is what I want to run. There we go. And now I'm going to run Java. That's the register server. So we do this. The register loaded. Oh, don't think I have the example over here. No problem. There's a solution to that as well. Give me 2 minutes. We'll see this thing work. In fact, here's where the source code is that I'm running. If this doesn't work after this, I'll give up and we'll do it next time. But it should work, actually. Oops, wrong one. Lectures is what I was looking for. Here we go, lectures. It's this code here. So I'm going to save it to my desktop. Okay, very good. Unzip it though this time. Very good. Which one is it? Actually, let me just do this here real quick. Let's just put it out here. Oops, leave that window alone. It's a little bit bigger so you can see what I'm doing. Oops, wrong operating system. Oops. We are going to be running a little bit slower on this end, which is why I hesitated doing it to begin with. RMIC, let's register the, ask the register registrar remote. Is it remote? Remote. Let's see if I can spell it correctly. No, where is it here? Ask the registrar remote. Did I not Oh, spelling mistake. So, my arrows aren't working. Okay, hold on a second. I have to type it in again here. Ask. Nope, it's not Java. It's RMIC. Ask the registrar. Is that correct? Remote. I don't know if that's actually loading. I don't know if the RMIC is actually running now. It should come back. It should have come back with that. I believe I have not edited it since the slide. It should have come back with something to the screen. So I may not have this working. But let me just try it one last time here. Ask the registrar server. Is that spelled right? Server. No, I'm going to have the same problem on this side too. I have not tested the example, which is the issue. Huh? No, it's on here. The RMI. I've started the registry. I have done actually all of the steps, unless I have. I'm following through. We did that part, RMI Registry. Then we have done, there's only 3 parts to it, and we did this part. The only problem is, the part that concerns me is that this server here is not loading correctly. So the RMIC is probably running. It's not supposed to come back with anything. So let me take a look at that error message one more time, however. Let me just see what that error message is actually. Let's just see what that error message is actually referring to. Server unexpectedly quit, exception remote. Nested exception is marshalling error, marshalling event. Nested exception is ask the register stub. Class cannot find ask the register remote _ stub. You know what I'm doing wrong? I'm loading the wrong one. I've got the wrong stub loaded. One more time. One more time. I wish my arrows would work in this, but they're not working. We have over here. It's looking for this file right here. I'm loading the wrong file. I'm not loading the stub. The RMIC needs to load the stub. So, RMIC. This will work eventually here. Ask the registrar remote _ stub. Aha. How much you want to bet this is going to work? Java. Ask the, if I can remember the name of this one now. What is this one? Registrar server, correct? No. Okay, I thought I had it. Okay, so I will definitely troubleshoot this problem. It's probably that the example, I have not tested the example, and I keep changing the examples. I could have an error somewhere along the lines. I will definitely have this fixed for next time. I wasn't expecting to demo it today, so I didn't actually test it ahead of time. So, long story short, I believe, in fact, actually, let me just do one more thing before I give up completely, because I'm still here. I still have this actually kind of loaded. Let me just try it on this end real quick here. I believe that the slide set is not matching, or maybe it is matching. I just haven't noticed it. Now that's the remote. Interesting. RMI Registry. That's the registry remote. It's this one's not even mentioning the stub. I believe that I've got two examples in one, and I'm mixing and matching the class files is what I'm doing. But let me go ahead and next time we'll see that work, or you can do it actually and see if you can get it to work. But long story short, to follow through for the essence of just giving you the concept, which was my intention for today, we should get, when we load the local student, if we actually have this one working correctly, if we have the stub working correctly, and we have the object actually loaded, and the stub matches the object, we have them, you know what, I got one thought before I give up on this, one thought there. I just thought of something actually. We've got, remote stub, see that's the stub. We have the, well, no, the thought's wrong. I thought I was missing another file. I thought it was a different file. But long story short, we will revisit that example. It's going to work next time. I believe it's probably the directory issue is what I'm thinking of now, actually. But what was your question? Well, that's the interface file is actually part of the. It's actually set automatically for us with the stub. So when we run it, it's essentially setting it for us. It should the steps that we're not missing any steps. This example actually works. I've done it before. The only thing is I haven't tested which files belong to which project. So and I have two RMI examples in there, and I suspect I'm switching the files. That's what I'm doing. But long story short, we are actually running, these are actually the correct steps in terms of the running, and the interface for it is set, and the interface is registered with the RMI registry, and the registry finds the object. The problem is my objects is not loading. So it's looking for it. It's getting to the point where it actually finds the registry, which is nice. It looks for the object, but there's some difference between the interface and the object, and there's probably because there's a mixed and matched example that I haven't tested yet, and that is causing a source of issues. Because I'm not getting the expected, definitely not getting my expected results, but it's not finding the remote object, which is part of the issue. So the server output, if we had a server output running and we had to ask the registry running, ask the registry server is ready, which we didn't get actually, because we never loaded the server. Actually, let me try something real quick here actually. No, I'm sorry. I'm not gonna do it because I've already wasted enough time with it. If we had server output, if we actually ran the server, what we would get in terms of the IP address from the calling IP, it would actually, when we're running ask the register server, it would say ask the register server is ready. We never got that. We got an error message instead, and it would, when we sent something from the client, if we take the next step to actually send a message to it, it should print out the register status that was received. It should actually, it's just nothing more than printing out information that the client is sending it. So it's just like the UDP and the TCP example where it sends a string and then the client sends a string to the server prints it out to the screen, essentially. But my server is not loading. The server is having issues, so. So in terms of, and here's the second part of the example, and it's probably why I'm mixing and matching, because the other part is to build it with a daemon. So I'm probably loading the stem for the daemon with the regular route. So let's see. We'll continue on here. If I, in the meantime, I'm sort of thinking about this while I'm still talking to you, because I know that the example works. I just don't know which ones go with which server goes with which client, which stub, in terms of those files. But anyway, in the previous example, the one we just tried to demo a few minutes ago, it requires us to have a separate Java application for the server. So in the server capacity, to register the remote object, make it available, we wish to have multiple objects now that are going to be available as remote objects. We only had one in that other example. And we need to run a separate server for each one that is created, called a super server, that registers one of each of the objects that is on the server. So to solve this problem, we use the RMI daemon. So we can run in the background RMID. If we run RMID back there, it's a daemon that runs that basically says that we can have multiple different server objects running. One process will replace the other server process and allow the remote object to be dynamically invoked. So one process gets replaced by the other. No adjustment to the interface or the client codes is required. So what we're doing in this particular case then is just a slight alteration, and perhaps my daemon code actually works because I think I'm dealing with those files. So client would send a message to the registry, same as before. This particular example, it determines the remote object location. The registry sends a message back to the client. This is so far we've gotten. Instead of going directly to the remote object, it would go to the daemon. The daemon that was running in the background would go out and find the remote object that's running out there and serve it back. And so basically functionality is executed back to the daemon. The daemon actually returns the functionality back to the client. So now we have a third party working in the mix. So we have the client, the registry, the daemon, and then the remote object. So the addition of that is just another service that gets started on the computer. And so maybe in terms of this, I will... The remote object that we looked at last time was the ask the register remote, right? Yeah, okay, so it needs to modify to inherit. Oh, you know what? That's what happened. It's modified already. I didn't make another copy of it. I believe we're going to get this example to work today, actually, because I just now mentally figured out what was wrong. Okay, so the last time we modified it. We modified the ask the register remote. Needs to be modified to inherit from a different but related object, activatable object, which is probably what it's inheriting from right now, which is why it wasn't running in the other mode, which is this is the same server I tried to run. So, which implies the remote object may be activated on demand. So for clarity, we're going to rename the class ask the register remote to ask the, oh, I didn't, I renamed it ask the register activation. Okay, so it should have been renamed. So ask the register activation, which is essentially going to be inheriting from a different, so this is going to extend activatable, and it implements ask the register interface. So no, so that wasn't the problem. So I thought perhaps I had edited that file to work with the daemon instead. So with the daemon, instead of inheriting from the unicast remote object, the remote object now inherits from activatable. So both the constructors are previously existing, and they need to be removed and replaced with ones that are going to have arguments for the activation ID and the marshaled object. It's kind of interesting. I was getting marshalling error messages, which is kind of interesting. So any activation code that we need to be replaced after the parent constructor is called. So other than those changes, the code of the remote object is pretty much the same as the previous example. So we change it, we have changed the most, instead of the server process, we only need to register the object as available for the remote invocation, and then we can create a stub for using it with the new daemon. So let's see. What we're looking at is ask the register RMID setup.java. So the server application has undergone some changes. And in fact, when I'm going to try this out, what I'm going to do is close all those windows and start it out fresh, so I can come out with something hopefully predictable in terms of troubleshooting. And then the first statement is going to include the main class provided by the first hint of the alterations. So we're going to look at the security restrictions, because now that we have a daemon up there, we've got security to configure for this configuration. So now we need to enhance the security restrictions. So we'll need to alter in order for the remote object to accept any connections. The remote object that communicates with nobody is not very useful, so we're going to need to make sure that we can register the security restrictions so it can actually connect with that object. So to accomplish this, you need a security manager to be available. So you set the system.security manager to new security manager, create a new instance of the security manager so that when you run it and this particular version of the server, it will register and open up the security so that the object can be invoked. And there's a security policy, so there's ask the register activation.policy, which is a separate file, again, that registers the information so that the daemon will actually serve up the object. So next you need to associate the security policy file with the remote object when it's activated. So we have the policy file simply states that the remote object is allowed to accept connections via the network. So it opens up, it's actually connected via the port, just like we saw in the UDP in the previous examples. So it should be known that although the policy file, oops, I'm not quite sure what's going on with my recovery. My system is probably from bad shape. So we have a text file, and it's called ask the register activation.policy. And we're going to grant permission for socket permission on the particular port that we're going to be using for this. So the RMI registry is still operating as it did in the previous example, so it has to be run first. All of the server-based processes are created, and the RMI daemon must run next. And then by default, very restrictive of any remote objects that there's going to be registered with it, so we have to make it available, so it's going to be activated. And then we have to define the security policy for the RMI daemon itself and allow the future remote objects to be allowed to register with its own security policy. So this could potentially open the door for arbitrary permissions that might have why this step is explicitly required is so that we don't open up the door to unrequested object invocations. So we have the security policy bottom line to make sure that only the requested objects are served up. And only the particular pieces that are available are actually available. So our security policy kind of would look like this. It's the RMID policy. When you run RMID, it looks for this particular text file in the same location, loads it up, and it sets the policy that's available. So, let's see. I could try running the example, or I could wait till I've troubleshooted it and have tested it to make sure I even have the right files for it. And I believe I'm just going to wait, actually. Well, okay. Now I'm destined to get this to work. So let's just do it. I'm going to close these windows, however, because I'm not convinced that my system isn't having issues. All right. So. Okay, close that down. RMID. Oops, I have to change to desktop. And you actually have to load it in the same directory as the security file because it's looking for that particular text file. And hopefully the text file is there, but I guess we're going to find out. It is. I think I did see it actually in the previous. Let's clear this. I put this on the top here. So let's see. You know what? Is RMID going to run? Yeah, RMID is going to run. Cool. Okay. Hello. RMID is running without my security policy. Okay, let me close that window. No problem. I was concerned if I didn't have it installed. So. Oh, let's see. Have not tested this, by the way, so I don't know if it's going to run or not. The other thing is as well, this is a slide set is perhaps about 2 years old, and I was written on a previous version of the Java EE, and so the other possibility that I was thinking about in my head while I was talking a few minutes ago was the fact that maybe some of the syntax has changed, some of the method calls maybe have changed, might be a little bit outdated. I'm running it with current 1.7, so it loaded. It loaded. So let's see. It could be a syntax issue. So what I'm going to do for you next time, actually, I've never intended actually to demo this today, but I got a little anxious and wanted to. But I'll test the files, and I may actually end up having to make some modifications to the code to adapt to newer versions and changes and things like that. But without actually knowing ahead of time, without testing it, I have no idea whether it would have even run or not. So next, we must register. So I just actually took the few minutes here just to see if it would work, and I have run the daemon. So the RMI Registry is running, which is the first step. The daemon is running, which is the second step. So now I have the daemon running. So now I must register ask the register remote object with the daemon and registry, which are already running. And so the registry program itself needs permission to contact both the daemon and the registry. Here's the policy file. I believe the policy file probably exists. I will wait till next time actually to go over it. And the policy file here, in terms of the example, let me type this in as well. Oops, wrong window. Not the other window. There's the other window. Oh, this is good. I can barely read that. Make it a little bigger so I can read it. There we go. Security. So now what I'm doing is after loading the daemon, I'm actually setting the policy file. Ask if I type it correctly. RMI policy. Ask the registrar RMI D. Set up without seeing the words on the screen. I suspect that did not work. I suspect that I have an issue because I did not get the expected response from that. So, lo and behold, that is not what I want out of that. So, I have to test this and rebuild the files and get a working example for you for next time. So, on this as well. But theoretically, once you load the daemon, the daemon should be able to communicate with the registry. So you're really still asking the registry, but you have a daemon out there that's going to serve up multiple server objects. So you have multiple capabilities going on at the same time. So it's worthwhile to note that the remote object ask the register activation has not yet been instantiated and will remain so until the first request. So it's not until the object is actually served out that an instance of it is created, which actually kind of saves server resources because you can have a ton of objects out there depending upon which ones you're using for the particular application. You're not going to have all of them loaded up, which is kind of important to know, which is kind of a difference between the servlet environment, which is kind of interesting. Servlets, when the server actually gets loaded, all of the instances of all of those little baby servlets get created. So it's nice that they actually waited until the object was first invoked before the instantiation occurs. So this is one of the main benefits of the daemon implementation, is that it conserves resources until they are required. And we saw in the previous example, well, that the one that didn't work, we would have made an instance of that object, that server object. The instance of the server object was not actually loading correctly. If it had loaded, we would have to do that for each one of the servers. If we were not using the daemon, we would have to register each one of them with the registry and make an instance of them before they were registered. So one of the error, actually it's probably important to know, I guess the error message that I was receiving was the registry complaining the fact that the server object wasn't available. Who knows why in that particular case. I will figure out why though. But long story short, the daemon is that third step that delays the invocation. So we need to make two more adjustments if we're going to use the daemon. First, we need to provide the client with a stub copy of the remote object, because the client's going to change slightly. In addition to the compiled interface definition. So we ask the compiler, after compiling the remote object, which is ask the register activation in our particular example, we're going to employ the remote invocation and compile it down to this, and compiler will whittle it down to just a stub that's going to be loaded. And so in here we're loading RMIC. We are actually loading the activation stub instead of the other one that was loaded. And then we're going to produce the final, the file name, ask the register _stub.class. That's the one I was trying to run, actually, which is the wrong one. I believe I modified it to work with the daemon. I'm going to stop with that because I'll figure it out eventually. It needs to be distributed with the client application itself. So all of these files themselves have to be bundled together. And the ask the register interface class and the local student client class, because the functionality is actually separated out into that other object, which is the client class that's going to actually connect to the server class. So secondly, while the client is unchanged, and my PowerPoint is saving again, now requires the security policy file in order to access the RMI daemon and the registry. So we changed the security policies slightly to accommodate for the daemon, which is the last step that we needed to do in order to make that example work itself. So the policy for the client says the connection may be made for non-privileged ports on the server that contain the remote object. So we're just adding more ports to it. When executing the client application, you need to include a reference to the security policy itself, security policy file, and the file should be in the same directory so that it can find it as in which you're running it. So, and it is a text file that gets loaded just like your Java files. So if we were, actually this is the output that we got from running the second client. No, what do we run here? Now I suspect, looking at the screen here, now I suspect I mixed and matched the two examples. And I bet this will work, but I'm not going to waste your time with it today. Because this is the out. This looks very similar to the output I was getting when I was trying to run that first example, but I was running the wrong. I switched them around, is what I did. So I think what I'm going to do is modify that so I can have clear and distinct names. They go example 1, example 1, example 1, example 2, example 2, example 2, because now I'm thinking I switched it. It may also be some deprecated, it might also be some lower deprecated methods or something as that as well. I believe everything compiled correctly, so maybe not a bad method call, but perhaps a switching. But we'll see. I'm going to fix that for next time. Or if you guys want to be extra A students, you can fix the example. You have the code, actually. You can probably, by going through it a bit slower, you can probably find out which files work for it. When I fix it, I think I'll put together a video, and I'll supplement this lecture with that video that says, here's the fixed version of that example, so you guys can see it work. But if I make any file changes, I'll repost the file. But I'll leave the UDP and the TCP in there, so I'm not going to take anything away. I'll just supplement it with some different naming. So, the local file client or invocation of the remote object is now functional again, well, theoretically. So after a lot of work we just did to learn how to do a CS483 check on a registration. So we'll look back on the RMI daemon. We note that the status messages are displayed with some extra logging information. Execution groups. We didn't really cover any of that stuff. In fact, this was supposed to be our introduction and our overview of RMI. And what I'd like to do next time, actually, is present you with a lot more examples of breaking down the functionality, which is really the purpose of the next kind of class meeting and the next visit we're going to have. So that, and to get into servlet technologies. A note on the RMI daemon. The benefit is to set up so we can run just one daemon and dynamically register objects when with the daemon, and the objects will immediately be available to the clients. So we do the daemon so we can, on the fly, register new objects and register new objects. So. And gives us a little bit more flexibility in terms of the running. These I have actually checked and they actually work. So these would be the extra resources that you would have. If you want to, and you're so inclined, you can go through and play around with the zip file that's going to contain all of the code for all of the examples that I tried to go through. And I, now that I'm kind of reviewing this, I can say it is kind of sloppy. It's hard to figure out which files go with which files. I've got TCP, UDP. I've got 2 register programs all in the same directory. So most likely, if you find the right file combination, the example will work. But don't worry about it. Don't worry about getting it working, because I'm going to work on that myself when I go through and sort this out and start doing some file renaming and make it a little easier, actually. And then I will probably end up recording a little tutorial video on how to run the RMI, and it'll be on these same files. So you'll see it running. It's just going to take, not today, it's going to take a little bit more time for me to do that. So I think it's probably time for another break. How far do we want to go today? Let's take a break. Let's take a break because we're not quite done yet. So let's take a break and we will start in with another topic. I have some IP information for you and some networking, internetworking stuff to give you. So 5 minutes, 10 minutes? Okay, 5 minutes. Perfect. See you soon.